introducing our speaker, let me remind you of the events in the coming days, really, rather than weeks at this point. On Friday, we do not have a lunchtime talk, but Melanie Mitchell is going to be talking about AI's challenge of understanding the world. If you don't know Melanie Mitchell, she's an extremely famous researcher from Santa Fe. She's one of the leading commentators on AI. She regularly writes for Nature or Science on some challenges raised by AI. The talk should be interesting. I do expect the talk to draw a lot of people. I might be wrong. I've said that before and was wrong. But I do expect that this talk will really draw from all of us in the university and possibly CMU as well. So the room might be packed for your information. Then we have the Thanksgiving break, so we're not meeting next week. And then we have 2 more talks, and we are done, sadly enough. Hein will be giving the talk on Tuesday, December 3rd. And Eric, who is not with us today, will be giving the last talk on Friday the 6th. And then the semester will be over. All right, today it's my pleasure to introduce Daian Flórez, who is a center fellow at the center. And we've been very lucky to spend the semester with Daian. She's a full professor and chair of the Department of Philosophy at the University of Caldas. She's also full professor of the National University of Colombia in the Department of Human Sciences. So she has a double affiliation. She works in the philosophy of science and technology. She has published 2 books, both in beautiful language, which I unfortunately don't speak, Spanish. The first one was in 2021, so only a few years ago, the thesis of incommensurability of theories, challenges, and implications with the University of de Caldas. And this year, 2024, the nature of technological knowledge, also with the Université Nationale de Colombia. She has recently published a chapter, also semantic change in the language of technology, in an edited book by OUP. So work in traditional philosophy of science, and incommensurability, and also in the philosophy of technology. And she told me to tell you that she's even funnier in Spanish than in English. So I'm glad to report that, but we won't be able to make a comparison today. So Daian, floor is yours.
Thank you so much for coming today. I'm so delighted to have spent these months at the Center for Philosophy of Science. You know, this is a dream come true. So the presentation today is just one part of a project that I have been developing with colleagues from Latin America and America. So your suggestions and critics will be so grateful, appreciated. So let's move on into today's agenda. I will outline the key points. Take this. Okay. Firstly, I'm going to defend 2 interrelated claims. The first one says that there is technological incommensurability. I am pretty sure that you are familiar with this notion because, you know, this thesis was formulated independently by Kuhn and prevailed, the guy, you know, the bar of every Friday, every meeting of Friday. And as probably you know, this thesis was formulated in a more sophisticated way in the 80s. And I would like to base my own position in that later version. The second thesis says that there are artifactual kind terms. I am pretty sure that Kuhn was a pioneer to coin that, that concept, because in philosophy of technology, this term has been used in the around 10 or around last decade. However, I am pretty sure that Kuhn used as a pioneer this term in his posthumous work as you can see here, this is entitled Incommensurability in Science or Plurality of Words. So, secondly, I would like to answer why this is important. And thirdly, I would like to share with you why I found Kuhn's position so insightful. So this is the third point of my talk. And the next point is the conceptual clarification, because I think that these concepts, it is necessary to develop my own position. So I would like to give you a definition of what technological incommensurability means and what artifactual kind terms means. The next points, or at the very heart of the talk, I will give you two historical cases. The first one case is based on case offered by Kuhn himself. Kuhn offered this case in his paper entitled What Are Scientific Revolutions? And he analyzes the semantic change during the transition from voltaic file to its successor design. The second case is a compelling one because it's my own case. So it's a compelling one because it challenges the way what we think, or what we usually think, the way Roman civil engineer has progressed. Usually think, there is a widespread belief according to which Roman civil engineer advanced without the benefits of science. So I'm going to show that that is completely false. And at the end of the talk, I will try to answer two objections, but I am pretty sure that you have more than that. Okay, so let's move on to the first thesis, and its scope. As I mentioned before, I would like to defend that there is technological incommensurability, and I would like to defend that not only between technological theories. This is a striking point because philosophers of science have overlooked that there is a wide range of technological theories, technological theories as complex as scientific theories. So I would like to mention only one, and I'm going to write there because, my pronunciation could be a little bit wild. I would like to mention this theory, the beam theory. This theory was formulated by the physicist Euler in 19th century. And according to Euler, civil engineers, a beam is a structural element that receives loads. So this is a technological theory that it is still important at the first stages of design in a structural engineer and in civil engineer. And I think that most of philosophers of science and even most philosophers of technology have overlooked these kind of theories that are really important to analyze in philosophy. But what I want to defend is that incommensurability is a phenomenon that occurs not only between technological theories, but only into designs. I am pretty sure that this sounds a little bit weird because you might think that the signs refer to objects themselves, but if you think more carefully, the signs have a theoretical structure, a very complicated structure too. In the signs, you can find theoretical commitments and very complex technological concepts too. I would like to mention just one example. If you review, for instance, the 5 patents of James Watt, it's crazy, you know, because Watt, it was, it has to, you know, to present to Royal Society not only 1 patent, but 5 patents. In that 5 patents, he used one operative principle. The operative principle refers to the expansive power of steam, and that is a technological principle. So that's what I want you keep in mind, you know, that designs have a very complex theoretical structure. So I know that incommensurability, even for philosophers of science, even if you are familiar with this concept, it is a very complex concept to explain. That's what I would like to explain that concept based on a beautiful historical example offered by Kuhn in his last writings. Okay, this is based on what are scientific revolutions too. Kuhn compares the meaning of the term of planet. So he says something like this. In Greek astronomy, planet means something like this. It refers, I know that it is kind sounds a little weird because, you know, for Kuhn, the meaning determines the reference, but I am pretty sure that you can follow me. So according to Kuhn, in Greek astronomy, planet refers to the following objects: the sun, the moon, and the planets that we can see without the help with the telescope, you know? But there is another striking feature according to Kuhn in Greek astronomy, and that feature consists of that planets do not have motion by their own. So if you compare this meaning with, you know, the modern astronomy, according to modern astronomy, planets have motion by their own. And another feature is, you know, that we regroup in other categories objects like sun and moon. For our modern astronomy, sun is a star and moon is a satellite. So I think that this is a really beautiful example because according to Greek astronomy, there is a distinction between 2 kinds of stars: fixed stars or constellations, and wandering stars. And wandering stars do not have motion by their own. They are carried along with crystal sphere because, you know, for Greeks, there is crystal spheres. So that's why they carry along with planets according to this paradigm. So maybe you can think in this part of the talk that the meaning of the term of a proper name, like, you know, like planet, correspond to the following set of descriptive statements. A planet is a wandering star, and you compare this descriptive statement with modern astronomy, it's not the same meaning. Planets do not have motion by their own. According to modern astronomy, planets have motion by their own. The planets are carried on along by crystal sphere. According to modern astronomy, you can say about crystal sphere that is the things that do not refer or fail refer according to philosophers of language. And the planets do not include moon and the sun. But this is the point of view that many scholars have subscribed to Kuhn. And I want to say to you that this is a wrong point of view because if you check or you read his unpublished work, like lower lectures, Kuhn was very critical about the descriptivist theory of meaning. So he subscribes a point of view according to which the meaning is a function of scientific principles, or is a function that you can derive of theoretical commitments. So this is not a point of view that Kuhn really defended, not only in his unpublished work. This is a work that most of my friends in Latin America could obtain of MIT archives, but also in his published works. So this is really he's not his point of view. Okay, this is the second thesis. I am following Kuhn in this thesis or in this claim. I would like to compare two main features according to which we can contrast or we can differentiate artifactual kind terms from natural kinds. Some philosophers endorse the position that natural kinds or artifactual kinds is, it's like a kind of terms from natural kinds. This is the point of view of our director. So the Kuhn point of view is very different. He says something like, you can find different features, and according to that feature, you can differentiate between natural kinds and artifactual kind terms. Okay, so let's move on to the next point. I would like to answer this question, what this is relevant. I think that as philosophers, we shouldn't overlook the conceptual richness and complexity in technology. I am aware that philosophers usually struggle with to the objects or artifactual objects and the terms or concepts that we refer to them to that objects. So I just would like to offer again one example. If you think, for instance, to the beam concept, it refers not only to the structure that can resist loads, but also it has a really amazing domain of reference for engineers. So it refers, for instance, to fuselage of an airplane. So that is why I think that philosophers have to take, or have to pay more attention to those kind of concepts. So that kind of concepts are as complex as scientific ones. And the second reason consists of in exploring the ubiquity of incommensurability. I think that it enables us to analyze semantic issues in technology, because it is probably if there are technological theories or conceptual or technological concepts in technology that we can find the same semantic issues as in science. So even if the thesis that I'm going to defend here are false, it is a fact. And the fact is that there are technological theories and there are conceptual or there are technological complex or technological concepts as complex as scientific ones. Okay. So let's move on to the next part. I would like to share with you what I found the more fascinating aspects in this version of incommensurability thesis. Kuhn tried to answer in this version to some objections that many philosophers direct to the first version of incommensurability thesis. And in this version, he localizes the semantic changes. And what he says is that the semantic changes occurs in one kind of type of concepts. That kind of concepts he called taxonomic concepts or class structures. So the taxonomic version of incommensurability thesis explains, I think that it is one of the most striking feature in this version in comparison to the 6.6 version. And discusses, explains the semantic change. The reason for this, or for this phenomenon, is that there cannot be homology between taxonomic or class structure. They don't share the same reference. I am pretty sure that if you ascribe a realist vision, this did sound a little bit weird, but anyway, we can talk about this vision, because I think in technology, this bizarre way of or these ontological implications or bizarre implications can deal with in technology in a more easy way. Okay, I would like to move on to conceptual clarification, because most of my colleagues in Latin America told me, Daian, I agree with your technological incommensurability version, but I am not pretty sure that your definition works. So I will try that this definition works in this talk today. So I would like to offer this definition in a little bit formal way. This is not a definition offered by Kuhn about, the taxonomical incommensurability, because, incommensurability is a relationship between two theories separated by a scientific revolution. So two theories, T1 and T2, are incommensurable if and only if the taxonomic structures or contents of T1 semantically differ from those of T2, that is a change of meaning and reference. That is what I'm going to try to explain according to the example of Greek, of Greek astronomy. So you can think that at first glance that the meaning of the term of planet, it could be a set of description, but that is not the position that could defend it, or a lexical definition, but that is not the position that could defend it. So maybe you can, you are struggle with, okay, what is the Kuhn position at the end? The position of Kuhn, what Kuhn defended about the definition or the meaning of a term consists of saying that the meaning of a term is a function of theoretical commitments. That's why you cannot separate the meaning of a term with the scientific principles. It is, like Aquinian point of view, a semantic holism point of view. Okay, so let's move on to my definition of technological incommensurability. I have been defending in the last 3 years what I call a deflationary version of technological incommensurability, because when I wrote this chapter for this handbook of Oxford of Applied Philosophy of Language, I tried to offer an argument based on technological theories. The argument follows more or less like this. If there are technological theories and its concepts change its meaning and reference, so you can find this similar phenomenon that Kuhn identified in scientific theories. But now I would like to extend this semantic phenomenon to designs to themselves. This is the version that I defended in this chapter. This chapter was published this year. So what is the main motivation to defend the strong version? As you probably know, engineers can design even when technological theories even yet formulated. So they can design or they can create a device without technological theories. And even though they subscribe a lot of theoretical commitments, that's why you can see, for instance, in what's patent. That's what I was talking before. So as probably you know, thermodynamics was development around 50 or 80 years later, when the steam engine was invented by Watt. You know, the steam engine was invented in 1769. And the book written by Carnot was published in 1824. So that is why I'm trying to extend this semantic phenomenon into the signs themselves, because engineers do not have to dispose this kind of theoretical resources, and even that you can find this this kind of change of meanings in his concepts are reference. So this is the deflationary version that I have been defending in the last 3 years. I am pretty sure that the term of operative principle sounds a little bit weird for you, because according to this definition, two technological theories are incommensurable if the terms used in the operative principle are not semantically equivalent. So maybe you can think, what is an operative principle? In philosophical literature, an operative principle refers to functional principles. It means that it explains how a technology works. And it can encompasses technological principle like the expansive work of steam, or it refers to a scientific principle. It doesn't matter. So it depends, you know, the way that science or technology progress. So this is the deflationary version. But this deflationary version, it is not logical, incompatible with the version that I would like to defend in this talk. I think this is a strong version because it refers to concepts or technological concepts. But I would like that you think that it doesn't refer to objects themselves, you know, because designs have a very theoretical or very complex theoretical structure. We usually think that when we think about designs, that designs refers directly to objects. You know, that if I say, okay, there is a technological incommensurability between designs, maybe you can think that I'm saying is that there is a semantic phenomenon between objects, that it is a little weird because objects do not have semantic properties. You say that the semantic properties are attribute or susceptible to ascribe to sentences by prepositions. That's what I think that this version could be sound a little weird. But that's what I'm going to try to show you, that designs have a very complex structure. It encompasses operative principles that can be scientific principles or technological principles. Okay, this is the strong version, and based on that version, I would like to offer what I call the taxonomic version, inspired obviously Kuhn to designs. D1 and D2 are incommensurable if the artifactual conterms used in the operative principles. As I said before, an operative principle explains how X technology works. Of D1 is not semantically equivalent to the artifactual conterms used in the operative principle of D2. So, oh my God, I don't know. Okay. I'm going to try to fix this. This is a feedback that some of my colleagues gave me. They tell me that I have to try to explain the difference, between the deflationary version, because it is a version that refers to technological theories or engineering theories and designs. I'm really passionate about this because philosophers of science have spent a lot of attention and a lot of time to examine or to analyze the logical structure of scientific theories. But when you analyze engineering theories or technological theories, you can see that they are complex as scientific theories. The difference is the domain of reference. So the domain of reference of engineering theories consists of artifacts or their materials. And you can find that they contain fundamental principles of designs or constructions of artifacts. This is an example. This is a really beautiful example of engineering theory. This theory was formulated by Kuhn. He was a French physics, and he tried to explain the function of steam engine before was invented by James Watt. If you check or you read the 5 patents of Watt, you cannot see like a articulated engineer theory, but you can see in the text of Kuhn something like that. And he based his explanation on Newton's laws and more or less in Boyle's law. So that is really amazing, I think. So if you contrast the structure, of engineering theories with the science or technological designs, what you can find is that the science are directed to solve practical problems. And they contain not only scientific principles or technological principles, but also norms. Or they have a normative, very complex normative component. And that normative component is related to, mandatory regulations. Like in Colombia, buildings and this mountain range must comply seismic resistance regulations. That kind of mandatory regulations you don't find in engineering theories. What you can find in engineering theories is like an unexplanatory, like an explanatory commitment to say how artifactual object works. I think that's really amazing. So, what are artifactual kind terms? Because this is the second thesis, or this is the second claim that I am going to defend here. I am following Kuhn in this part. So he says that you can distinguish between natural kinds and artifactual kinds according to these features. The first one features, according to Kuhn, is that X is a member of a natural class because we can group X based on an observable similarities and differences. You can maybe remember this example in his postscriptum. Yes, this is a very famous example. So you can group in a family dogs, or in another family geese, and in another family swans based on their length of their necks or the ratio of their heads. So this is quite amazing because it's in philosophy of biology. Philosophers of biology call this kind of way to group some members phonetic classifications. And as you know, in philosophy of biology, there are other ways to group members according, for instance, to the evolutionary evolutionary information. So, but this is the way that Kuhn defend that we can group in a member natural objects. So he said that you can only take into account the morphological features because this is he defends a parsimonious way to natural kinds. He doesn't commit to a inflationary explanation of natural kinds like Kripke's or Putnam, that you have to assert that there are essence between natural objects in order to group some member. So this is one of the characteristics that can give you information how to group in a member in a natural kind. So the second feature, okay, I would like to contrast this feature to the way that we can group artifactual kinds. He said something like this in his plurality of words on his posthumous work. He says that when we contrast natural kinds with artifactual kinds, we group artifactual kinds according to their function. So this is an example that I think that could be nice. As you know, motors convert any kind of energy into mechanical motion. So you can see here, this is a steam engine. So an steam engine can convert thermal energy into mechanical motion. And you can see electrical motor, and an electrical motor convert electrical energy into a mechanical motion. So you can put here an internal, any other internal combustion energy of 4 times motor. So what Kuhn says is that you can group in artifactual kind terms objects or artifactual objects according to its function. So I think this is a really clue to try to group this kind of objects. This is the second characteristic, or this is the second feature. And I think that this is really important feature. He says that both natural kinds and artifactual kinds have to satisfy the non-overlap principles. And what we can understand about non-overlap principle, he says something like, just as there are no dogs, that there are cats, there are no plays, that there are cats. So I know that this is quite contentious, especially the last part. But what he says is that when you try to group, for instance, dogs, you group them into the genus of canis, and you group cats into the genus of felix. Yeah, and you have to do the same for artifactual kinds. So you cannot group motors, I don't know, into the class of airplanes or refrigerators because they don't have the same function. And if you try to group this kind of artifactual kind terms, this is the clue to try to group them. Okay, so when you read Kuhn, his last writings, unfortunately, you don't find a definition of what function means. This is a reality. You don't find a definition of what does function mean. And I am aware that this is a notion that is very important in philosophy of technology. And unfortunately, in philosophy of technology, we don't have a full-fledged theory. What we do have like three kind of explanations or accounts. We have physical explanations of artifacts that explains the mechanisms about how a technology works. an intentional explanation, and in this kind of account, what philosophers consider are the intentions of designers. And at the end, we have teleological explanations. And when philosophers consider teleological explanations, they are thinking about users. But we don't have a full-fledged theory of functional explanation. This is the kind of what we have to do in philosophy of technology. So that's what I would like to offer. A preliminary definition. I am pretty sure that it could be, a contentious definition too. Item is a member of the artifactual kind term, X only if it refers to a human-made physical object, because many organs in our body can be described as a function in a biological terms too. And B is used by human agents to functionally contribute to the performance of a task. So I would like to offer the next example. Consider the term motor. Motor is a kind term because different type of motors can be grouped by their function, such as the steam engine. The steam engine is a member of the artifactual kind motor, since it refers to a human-made physical object. As you know, it was invented by James Watt. It's used by human agents to functionally contribute to the performance of a task. The task, according to which this machine was invented, was rising water from mines of England. And its physical mechanism contributes to the performance of the task established by human agents. Its physical mechanism is to convert thermal energy into a mechanical motion. So now I would like to offer the two historical cases. I hope that I have fine time. Okay. So I really like this case. This is a case offered by Kuhn in his paper entitled "What Are Scientific Revolutions?" But I would like that you distinguish, although you are careful with these two levels, the ontological level and the conceptual level. So that's what I'm going to ask you right now, because according to what I said before, philosophers usually struggle with the distinction about the objects or material objects and the concept that you are to refer to that objects. So this is the diagram, the original diagram designed by Volta. And as you can see here, this is an electrical cell. In our modern jargon, it corresponds to ions. But in Volta's jargon, it refers to zinc metal. This is a zinc metal. And silver metal, and at the end, you can see here the well-floating paper. So according to Volta, the battery should have this strict order. And why he thought that? Because he invented not only the battery, but he also offers a technological explanation to say why the battery produces electricity. And the Volta's technological explanation is well known as the contact pi theory. So according to the contact pi theories, the electromotive power of the battery is the contact of the metals. So if you compare this design, I'm going to move on this design, the successor design. What you can see here is that metals are separated by the wet blotting paper. Our home batteries have the same structure. Okay. Silver has been replaced by another element, more efficient, more sustainable. But anyway, our home batteries functions following this arrangement of the elements. So what you can see here, according to this design, is that electrophysics, coetaneous fellows of Volta realized that when they saw this design, that there were like a corrosion or an oxide or oxides of metals. So they derived the conclusion that was taking place was a chemical reaction. So there was this technological theory was replaced by the electrochemical theory. So you can consider that the electrochemical theory is a technological theory too. But obviously, this technological theory proposed a different operative principle, and that's why you can see that the arrangements of battery are completely different. So if you check this, the meaning of term unit element lies in the arrangement of components in a battery, a zinc disc, a silver disc, and a piece of wet blotting paper. This kind of arrangement depends of the principles in which it appears. That is the Kuhn like to like highlight. That's the point that Kuhn wants to highlight. Okay, this is the first case, and that what I like that you keep in mind is that there are two technological theories. The theory of Volta, according to which the electromotive power consists of the contact of metals, and the electrochemical theory. This is the first argument for technological incommensurability. So two designs, Volta's design and Fabroni et al. Design are incommensurable if and only if the artifactual kind terms. I think that a unit element could be considered an artifactual kind term using the operative principle. That operative principle states that the electromotive power is caused by the contact, and not semantically equivalent to use the operative principle, which states that the electromotive power is caused by a chemical reaction. And for that reason, cannot be subsumed or derived. Okay, so I would like to offer the second case. And this second case, as I said, as I mentioned before, is a remarkable case too, because we usually think that Roman civil engineering has advanced without the benefits of science. But when you read some marvelous books like Vitruvius' book, you can change your mind, or you can change your point of view. That's what I would like to compare things. Now, in this case, I would like to highlight, or I would like to insist in the necessity to distinguish between the ontological level and the conceptual level. But in this ontological comparison, what is concrete? Concrete is a mixture for civil engineers. So it's a mixture of fine aggregates and coarse aggregates. So the difference consists of, you might think, the difference consists only in pozzolana. And pozzolana explains why you can see or you can enjoy, for instance, the Colosseum or many Roman structures so durable during centuries. But actually, you can find pozzolana in modern concrete too. My civil engineers colleagues tell me, no, Daian, you can find this fine aggregate too. It's not really easy, but you can add that fine aggregate in modern concrete too. So this is not the difference, actually. But when you review, for instance, the binding agent, and the binding agent has too many functions to unify the aggregates but gives strength to. You can find this, for instance, the invention of Portland cement. This is a really striking feature that's you cannot find in ancient Roman concrete. But I would like to draw your attention in the next one feature, and what is the way that Roman explain the solidification of Roman concrete. According to Vitruvius, the solidification principle is based on fire, because he endorsed the theory of four elements. So that's what I was told, that I was telling you, that I think that this is a striking case, because we usually think that Roman engineers can do many things without science, but that is completely false, because they base on the science of their time, and the science of their time was Aristotelian science. So according to Vitruvius, the fire element is indeed the force that causes concrete to become firm. So if you review how not only modern civil engineers explain how concrete became solidified, or physiochemical scientists, they recur to hydration reaction. This is a technical, or this is a technological principle. This is a not scientific principle. This is a technological principle. And this technological principle is based on one of scientific principles. You can formulate more than that, but one of the most important scientific principles is the conservation of matter, of mass, was formulated by Lavoisier. So this is the quote by Vitruvius. According to Vitruvius, the reason why lime makes a solid structure of being combined with water and sand seems to be this, that rocks, like other bodies, are composed of the four elements. Those which contain a larger proportion of air are soft, of water are soft, from the moisture of air, earth, and of fire, more bitter. So this is really amazing, because if you read the Architectura of Vitruvius, you can find that he tried to be compatible two theories that in ancient times were completely incompatible. For instance, atomism and the theory of elements. Aristotle rejected vehemently atomism. So this is really good. This is the second argument. So two designs, Roman's design and modern design, are incommensurable if and only if the artifactual concerns concrete using the operative principle of the solidification process and its components was explained by Vitruvius based on the theory of the four elements. And when you compare this with the operative principle of the two, which states that the process is a chemical reaction, therefore they are not, as Kuhn says. Actually, Kuhn says that not in the structure of scientific revolutions. He didn't relate incommensurability with problems of translation in the structure of scientific revolutions. Or I mean, in 1962, he began to talk about problems of translation in his postscriptum. Okay, so I'm going to move on to the objections. I don't know what is my time.
Almost done this time.
Done?
Almost.
Almost. Okay, so to go to the objections. But before that, okay, maybe you might think that in the case that I'm going to offer here, you can think that there are no conceptual changes at all, you know? So just I would like that you keep in mind the meaning difference in this concept, in the concept of element, according to Aristotle, and I think that Vitruvius based on Aristotle theory. And I am thinking in Aristotle because he offered the most articulated definition of the term. And Aristotle said that an element is something that can be analyzed in other bodies. And you compare this definition to the Lavoisian definition or Lavoisier definition, it is completely opposed. Lavoisier says in his Elements of Chemistry is that an element is something that cannot admit further analysis. So that's what I'm saying, that you can find in this case technological incommensurability or a different meaning in these two designs. So I would like to advance these two objections. This is an objection, I don't know, that some of my colleagues shared with me. I don't know if it is good, but anyway, two of them offer me this objection. So that's what I would like to answer this possible objection. They say that, okay, Daian, but I don't find a real difference between scientific incommensurability and technological incommensurability, because when you explain the case of Roman concrete, you have to appeal to scientific principles. But I wouldn't be worried about that, because many scientific principles explains the way that artifacts work too. There are no artifacts that can be violate the laws of nature. So if we don't have an advanced scientific knowledge, or we don't have a scientific knowledge, we can appeal to that scientific principles to explain the way that artifacts work. So this is a kind of, this is a line of way to respond to that objection. But the other ways that I distinguish between science and technology, maybe you can find difficult to distinguish between scientific incommensurability and technological incommensurability if you endorse a point of view. Oh my God.
It's okay. Don't worry.
Okay, I have this. This kind of. Fine. If you endorse a point of view like this, a sociologist, I don't remember, he passed away, I think the last year, but he considered that there wasn't a distinction between science and technology. And I subscribe a distinction between science and technology. The main distinction is based on its cognitive purposes. So this is, as a common sense way to distinguish between science and technology. So you can say, in science, you try to explain or you try to understand the phenomena, and in technology, you try to control or to transform the reality. So this is a way to try to respond. Okay. And the second.
No, we don't.
It's okay. Oh, the last one objection was the strongest objection, but it's okay. So thank you so much. It's okay.
Yeah, okay. You want to conclude?
Yeah, I have to try it because.
Don't worry about the pointer. It's fine.
Okay. Check if I.
Then just use the arrows on the computer.
No. Oh, yeah, I think so.
Or the space bar. Next page.
Next page, okay. Okay,
No, I think you should conclude now.
next page.
Just someone will ask a question.
Okay,
Thank
in
you.
this talk, I have argued that there is incommensurability in technology. I trust that the conceptual definitions I have provided will serve as impetus for philosophers to take this semantic phenomenon in technology seriously, as illustrated by the cases of the multi-point and concrete, the objects themselves change within this domain. Perhaps this could serve as a starting point of encouraging a renewed engagement with technical philosophical notions such as meaning and purpose.
I will take a 2-minute break and then we have plenty of time for questions.
So